I got these 4 questions wrong during my SAT speedrun. 2 questions on inequalities, a question on polynomial division, and a question on the vertex form of a quadratic. In this quest to redeem my honor and escape the dreaded college board gulags, I'm going to work through these problems again to help you avoid my mistakes and help me avoid the gulag. Let's dive into question 1 and see why I got this inequality question wrong. So in this question, we're looking at 2 inequalities. Y is greater than or equal to 2x plus 1, and y is greater than 1 over 2x minus 1. We need to find which quadrant contains no solutions to the system. So first, let's look at these equations graphed on the plane, and then see where points lie on these equations. First, let's draw the number plane for our lines. Now, let's draw our lines using some fun Christmas colors. We gotta keep math somewhat interesting. Let's draw a green line for y is greater than or equal to 2x plus 1, then a red line for y is greater than 1/2 x minus 1. Let's look at what points land on the correct side of these inequalities. So here are 3 green points. As you see, they all land above the green line, and these points are in the correct region of the inequality. So in general, we can shade the top region of the green line, as this is the correct region. Let's look at these 3 red points. Similar to the green line, the red points land on the top of the red line, or in the upper region. Let's shade the region in red. The Christmas theme intensifies. But we have a dilemma. Where do we take the problem from here? We need to find the region that solves both inequalities, so that would mean we need to find the overlap of the green and red region. So let's ruin our lovely Christmas theme and add a color purple. We finally have the solution region for this problem. As we can see, the purple region, the overlapping region, does not include quadrant 4 of the xy plane. Now that we're back and we just saw in the animation that quadrant 4 does not contain any of the solutions, our answer is C. Which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3? The easiest thing we can do here is put all the variables to one side. So we have 3x and 4x. Let's subtract a 3x over. So we have negative 5 is greater than or equal to x minus 3. And if we really want to make it easy, we can move the 5 over and add 5 to both sides. So we have 0 is greater than or equal to x plus 2. Now we can just plug in for negative 1. Is 0 greater than or equal to negative 1 plus 2? No. 0 is not greater than or equal to negative 1 plus 2, which is 1. And just to verify, we'll see that 0 is greater than or equal to negative 2 plus 2, because it's equal to 0. 0 is greater than or equal to negative 3 plus 2. That's negative 1, and so on with negative 5. The trick here is to keep all variables to one side and make one of the sides a constant number. It makes it much easier to solve, and you won't make simple math mistakes with less areas to plug in. For a polynomial p of x, the value of p of 3 is negative 2. Which of the following must be true of p of x? X minus 5 is a factor, x minus 2 is a factor, x plus 2 is a factor. For me, these are not compelling answers. I think the answer is D, but I don't really have a way of showing it. So let's make up some polynomials where p of 3 is negative 2. So for example, x minus 5, and let's look at a x squared, you get like x squared minus 11. You plug in 3, you get 9, minus 11 is negative 2. We certainly see that x minus 5, x minus 2, and x plus 2 do not divide the x squared minus 11. So A, B, and C are wrong. But how do we know D is right? Well, let's do some polynomial division. So we have x squared minus 11, and we're going to divide it by x minus 3. What does that look like? Well, to divide this by x minus 3, we need to multiply the x minus 3 by x to get x squared minus 3x. And then we see that this cancels out the x squared. We have an x on top. And now we have minus 3x minus 11. To divide further, we need to multiply by negative 3. So we have negative 3x plus 9. Cancels that out, and this results in negative 2. So here we see that we have a remainder of negative 2 for the x squared minus 11. So we know D is the correct answer. It's just a trick about how polynomials divide each other and what their remainders are. In this question, we need to find the equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation. This means we're going to be finding the vertex form of the quadratic. The vertex form of the quadratic can be written as y is equal to x plus h squared plus k, where the h is the horizontal shift and the k is the vertical shift. Let's look at some example questions. Let's say we have x squared, and that is our quadratic. That will look roughly like a quadratic right at the origin. We know we're going to have 0, 0 as our vertex. So if we were to write this in vertex form, we would write y is equal to x plus 0 squared plus 0, because our x position is not shifted and our vertical position is not shifted. Let's look at x squared plus 1. If we were to draw this, we would see that the quadratic is shifted up by 1 and it has a vertex of 0, 1. Writing this in vertex form would look like y is equal to x plus 0 squared plus 1. And now let's look at a third example, x squared plus 2x plus 3. If we look at this a little closer, we might be able to notice that this can be rewritten as x plus 1 squared plus 2. And that can be drawn as this quadratic shifted to the left by 1 and up 2, which can be seen here with this horizontal shift, while the vertical shift is in the direction we do expect. Now that we're back, let's look at this again. The vertex is at x is equal to 1, and it looks like it's at y is equal to negative 16. So let's look at our possible answers. We know a and b are not in vertex form. C is certainly not in vertex form either. D would be clearly the best answer here. And of course, it has the minus 16 and the minus 1, which matches with what we expect for the vertex here. So we have our correct answer as D. If you're still here, thank you for watching. I hope you enjoyed the animation I worked on for question 1 and everything else throughout the remainder of the problems. And please consider liking and subscribing to catch some of my future content. Have a wonderful day.